Hey guys, Mr. Marone here. Welcome back in. We are now into our first lesson after midterms. We're in lesson 6.2 here, and we're going to break it into two shorter segments. We're starting to focus in on quadrilaterals now. We looked at a lot of different polygons, internal and external measures, and their angles, and so now we're going to kind of hone in here and focus just on quadrilaterals. And the first part of this is going to be discussing kites and trapezoids. So the kite is our first figure, and it's a quadrilateral, it's a four-sided figure, and it has two pairs of consecutive congruent sides. So if we look at our diagram here, you notice that AB and BC are congruent. They each have one tick mark. So they're the shorter sides of the kite, and then our two longer sides are going to be congruent as well. So those are our two sets of congruent sides, and they're consecutive, meaning as we continue around the figure, they are congruent rather than being like opposite each other or anything like that. So the other big thing here that you will notice is that we end up bringing out a perpendicular bisector type of setting here. AC and DB, these dotted lines, do create perpendicular lines. And BD is, because we've got these equidistance here, that point B is the same distance of each of these two segments, that makes this a perpendicular bisector. So that tells me that this side here and this side here, AX and CX, are going to be congruent as well. So we end up really having two sets of congruent triangles. You've got this set here, those two triangles are going to be exactly the same, and then you've got this set here. They're going to be exactly the same as well. So it's kind of a neat setup here, having the ability to hone in. It makes solving these much faster. So I want to do one example with you guys, and then let you try one, and that's it. So if we look at this kite, we know we can mark AX and XC are congruent. So if we look closely at this, they want to know what's the measure of AXB. Well, we said when we have our two diagonals meet, they create perpendicular lines. So that measure is just 90 degrees. They then asked if AX was 3.8, what was the measure of AC? Well, since AX and XC are the same thing, we would just combine them. So 3.8 plus 3.8 is going to give me 7.6. Okay, now if we look at our third example here, I'm going to take out this other stuff just to give us some freedom here. They said if the length of BD was 10, does BX equal 5? So they're telling us the whole length here is 10. And if we look closely at the picture, we knew we had one perpendicular bisector, that AX and XC were split. But if you look closely, BX and DX are nowhere near the same size. So no, because of these being different side measures, we don't have a perpendicular bisector. So in other words, AC is not a perpendicular bisector of DB. So what I'd like you to do is try example 4. We'll pause the video, see what you come up with, and when you come back in, we'll have all the answers here. They want you to find angles 1, 2, and 3, given the information that you have in that picture. Go ahead and give that a try. All right, welcome back in. So we know when the two diagonals meet, we've got a right angle. So angle 1 is 90 degrees. Well, all four of these inside here are all going to be 90-degree angles. So I've got a 90-degree angle there and there. That gives me a triangle to work with on each side. And like I said, these are two congruent triangles. If we folded this kite along QS, those triangles would be exactly the same. So if we solve this triangle, we have that triangle right there. In other words, the 35-degree angle is the same as angle 3 if we were to fold them along QS. And if we just solve for our missing angle in QTP, we get that angle 2 is 55 degrees. If you guys have any questions, please bring them into class, and I will see you guys then. Have a great day.